This question has it's like a big W graph, and then it asks us three questions. It says, where's the limit defined? Where's the function continuous? And where's the function differentiable? These are increasing levels of niceness of functions that we deal with in math and science. So what's going on? Well, first off, what does it mean to say a limit is defined? Well, it's got to be the same from the left and the right. Let me give an example. So notice if you have a graph that goes like that and has a solid dot or whatever, and then has an open dot just below it, and then continues off, whatever, then right there, it's not, write that so well, the limit is not defined. It's got to be the same, not defined. It's got to be the same from the left and the right. You can't have different heights from the left and the right. That's what it means for a limit to be defined. Same from the left and the right. Well, this function doesn't have any left and right missing like that. So it's good. It's good everywhere from 0 to 5. This is 0 all the way to 5, everywhere from 0 to 5. It's good. Next one. Where is it continuous? And you know what continuous means. It just means you don't lift up your pen, right? Just see it's all just connected all the way. You never have to pick up your pen. So that's also everywhere from 0 to 5. Now, the third condition is probably a new one for you. Differentiable. Differentiable means smooth, not jagged. And you can see what we're talking about right there at 1. It's it's jagged, and right there at 4. It does a little, it's not smooth, huh? It does a little jag move. Right there. It has a little crook, right? It's jagged. We don't like that. That's not, we'd rather it kind of came in and rounded out nice and smooth. We don't like those jagged changes. That's not smooth. That's what we call not differentiable. That might be a new word for you. That's next. That's a preview coming attractions, chapter 3. It's going to be all about derivatives or getting us ready for that, showing us what it looks like on a graph before we start cranking it out with functions. So differentiable means smooth. So therefore it's not smooth at 1 and 4, but everywhere else. So that's why they write these intervals. See how they're 1 and 4 are not included? Let me explain that notation. You might look at that and go, well, how's that any different than just saying like, 0, oops, getting scribbly there. My pen is done. There we go. How's this different? Let me just write it here. Than just saying 0 to 5. Well, if you said 0 to 5, that would include 1 and 4. Whereas this does not. Well, sorry. Why does it not include it? Well, when you write something like 0, 1, that does not, let me make that more clear, parentheses does not include 0 or 1. Whereas if you do brackets, that includes 0 and 1, it includes the endpoints. Do you remember that? Brackets have straight edges. You're straight on the 0, straight on the 1. You put parentheses, you're saying, hey, look, I'm around the 0 and I'm around. Just think of it like it's rounded. You're around 0 and 1, but you're not right on. Like you can be, you can be close to 1, like 0.99999, but not right on 1, just around 1. So when they put parentheses 0, 1, 1's not included, then they put parentheses on the 1 there. So 1's not really included in either interval. 1's not included. Same thing with 4. When they do the parentheses on both the 4's, 4's not in either interval either. This is just a fancy way of saying everything from 0 to 5, not including 1 and 4, which is exactly right. At 1 and 4, those are jagged spots. It's not smooth there. It's smooth everywhere else, right? And that's also, by the way, you might say, why didn't they include like 0 and 5, the endpoints? Well, right here they said, treat the endpoints as not included. That's why we have parentheses on all the endpoints. And so 3 levels of niceness. Is it same left and right? That's limit defined. Even higher level, is it continuous? Got to keep connected all the way through. Yeah, it is. And then the highest level, is it smooth everywhere? Not quite. Not at 1, not at 4. Everywhere else but those two. And there we go.